Hey there, I'm Joe Weems. Before we get into the video, I want to remind you about ng-conf 2023 happening in Salt Lake City, Utah on June 14th and 15th. Head over to ng-conf.org to check out the speakers, check out the talks, and to get your ticket before they all sell out. We'll see you there.
Everyone is having a fantastic ng-conf here. Yeah? It's pretty good. Throughout ng-conf, I've been having little conversations with people all over the conference, trying to understand what you already know and don't know about blockchain. Because based on what you know and don't know, we're going to have very, very different secrets to decipher here today. But as was said, my name is Fluin, and I was the task runner yesterday. So that's probably my biggest to fame. I'm also head of developer relations at Chainlink Labs. And as she said, I used to be on the Angular team at Google. So we're here today to talk about blockchain. And what I've realized through all those conversations is that a lot of people don't even know what you can do from a developer standpoint. We all hear these things on the news about NFTs and prices and things like that. But what I want to do today is pull back the veil and reveal a world of software engineering that's actually about building things and creating value for users. So, does anybody know what this is? It is an axolotl. That is a good answer. That is correct. There's other correct answers. This is an axolitl, which is an NFT. Scary. Ooh, NFTs, right? We hear a lot about them. A lot of people don't know what they are, right? And because there's this whole market trading thing like this. But I want to show you what an engineer sees when you look at an NFT when you know about blockchain. When I look at that little tiny GIF, I actually see a program that is executing in this shared compute environment known as the blockchain. So if you think about all these blockchains you've heard of, like Ethereum, and maybe Phantom, or Avalanche, or BNB, there's all these chains out there. And what's happened is we've built this fantastic system for building consensus through immutability. So you can actually deploy a contract, as we call it, a smart contract, onto the blockchain, and it's just a little program that runs. And so when I think about this NFT, I'm thinking, hey, it's just a class, right? It just has variables. It's got methods that you can call on it. And so because you have this consensus layer, because we all are looking at the same source of truth, we're all looking at the same variables, we all come away with the same understanding. So it has methods like owner of. Who owns this NFT? It has methods like transfer, so I can send someone else an NFT. Right? By just calling that method and changing the owner property, that is how an NFT moves around the world. And then you've got methods like token URI, which is what is that picture that it's actually pointing to? Right? All of this is just a program that's executing across the blockchain. What's really crazy, though, about the blockchain is that instead of the trust that you normally have to do when you buy or sell something, right? This always happens. There's this moment where you either need like an escrow party, or I'm going to give you the cash and you're going to give me the thing, right? And we're going to trade and we're going to trust each other that's going to happen. Instead of relying on that, you can actually build systems and programs that do this in a way that you don't have to trust an individual. You're trusting systems. You're trusting the shared truth that is created on the blockchain. So what this means is I can build another smart contract. I can write another program that says that if you send me the amount of money I request, I will transfer the ownership. And this is automatic. It's going to execute according to the program in a fully transparent, decentralized way. I cannot interfere with that. I cannot change the program. I can't do naughty, bad things. So we all hear about blockchain being a place where people are buying and selling and trading. But you can also think of it as this large shared computing environment. I was having a conversation in the hall about 10 minutes ago, and we were talking about, like, how does this work? Like, how, like, people are getting paid for having files on their hard drives, or getting paid for, like, running GPU? The simplest explanation I can give is that in all of those cases, you're donating resources into this shared network that then people that use that network pay for. Right? That is the fundamental that secures these blockchains. I want to tell a brief story, because throughout my life, for most of my life, less now, but I used to love McDonald's. Yeah, McDonald's fans? I don't know if anyone would be like proud of that. It's kind of hard in 2022. But my favorite thing that McDonald's ever did was they had this giveaway, the Monopoly game. Did anybody play the Monopoly game? Okay, see? We got some Monopoly fans in here. So you'd buy a large fry and you get these like little peel-off stickers, And if you got all the right stickers, you'd get them like a Monopoly, and you'd win a car or a house or a trip, and it was amazing, right? But you, as someone that was playing that game, you had to trust in the system. And that trust was not well founded, because from 1989 to 2001, there were almost no legitimate winners. The people operating that McDonald's game took all the best prizes and they gave them to themselves, or they sold them to their friends, right? This is a system that you had trust in, and they violated that trust. That's a long time for a big scam like that to be going on. Like, eventually the FBI got involved. There's whole documentaries on this, but the fact that we have these systems that we rely on that we think are predictable, but they're not because they have a human element is very important. So in these conversations I've been having, lots of people have different thoughts about the blockchain, right? It's new, it's kind of scary to a lot of people. I heard someone use the term evil or scam, but like when you think about this computing environment, it's also very, very exciting. And I don't want to hide things. I want to acknowledge the benefits and flaws of blockchain, right? Because if you look at, like for example, this website, wrecked.news, you'll see that over 200 million was stolen in August. August alone of this year, 200 million was stolen through people making mistakes in the way they built these programs, these autonomous systems that were built and deployed to the blockchain. They had problems in them. And so when there's problems in a financially connected system, you can just kind of do the wrong things. You can be very malicious. But I want to acknowledge that this is not a problem that is unique to blockchain. If we look at traditional development, we have similar problems. We have trust problems, right? In the US in the last 2 years, over 200 million people have had some sort of personalized information violated through data breaches, right? These are companies that we all know and trust. Apple, Twitter, IKEA, Ancestry.com. Like, we trust them with our data, even sometimes without our knowledge, right? The census leaked 200 million people's information in 2020, right? We don't always get to choose which systems we're using. But fundamentally, this comes down to software problems, right? If they had secured their system better, if they had written better software, this wouldn't have happened. But underlying these traditional systems is a huge degree of trust. You always have to trust every partner, every website that you interact with, and sometimes even those that you don't interact with. So what can we learn? Bad security is everywhere, right? This is just a problem in all software development. But we really need to think more about security, so that's a little bit on us, regardless of what industry you're in. And there's also this question of optimization. What are the trade-offs that you're caring about? When you buy into and you use traditional systems, you're trusting. You're relying on and assuming that they are going to fulfill their part of whatever agreement you have, your contract, the social contract that you have. And most of the time that works out. But there's more and more cases where that doesn't work out. Whereas in the blockchain world, it's a little bit more difficult to use. You have this thing called private and public key cryptography, right? Like where I have to maintain the keys, and if I do something wrong, I can lose my money. So, but what the nice thing is that cryptographic truth, when you rely on a system like a blockchain, the control is in the user's hands, right? You ultimately end up being responsible for what you do on the blockchain and what you do with it. And what's nice here is that transparency is unavoidable. Every contract you interact with, all of the source code is published. All of the assembly that it's going to be executing on the blockchain, it's all visible and it's immutable. Someone cannot take a system that you're using and then just suddenly take that system away. They can't change it to do malicious things. So today's plan, we started already talking a little bit about why blockchain is interesting and reminding everyone that this actually is a development platform that you can write contracts, you can build apps on it. I'm going to go next into some of the learning paths, so if you're actually interested in this, and I'll talk a little bit about the architecture. And then last, I'm going to do a demo. I'm actually going to build a smart contract and a web app that connects to it, and we'll take a look at that. So let's talk a little bit about learning paths and architecture. One of the ways that you can think about blockchain is, as a front-end developer, we rely on backends all the time, right? JSON, RESTful APIs. I'm used to hitting these backends that someone built, that I trust. You can think of blockchain in the same way, where I'm now just connecting to a system, and I'm going to get back data. So you could build an Angular front end and use a blockchain back end. So if you're thinking about getting into this, I would go through a progression. I would first build a front end that connects to some existing data on the blockchain, right? There's lots and lots of data there. Connect to some existing source, surface it in your application, see if it's useful, valuable to you. One step past that is connecting to an actual dApp, or a decentralized application, as these are sometimes called, where now I'm going to actually make changes. I'm going to do things on the blockchain. Decentralized exchanges are a really popular example of this. It's actually like, if a smart contract exists out there, I can build a new front end to that, right? I don't need anyone's permission to build a new front end to some backend system that exists on the blockchain. Then I'd say go and build your own dApp. And then finally, productionize. Think about security. Think about the user. Think about the experience that they're going to have. So one of the fantastic tools in this ecosystem is called Remix. It's one of these browser-based IDEs, but it's built entirely for blockchain development, where you can deploy contracts, right? This is the term, where you take your code and you're actually going to run it on that shared compute environment. So a little bit more on if you're trying to think about how to run this. So you're sticking with your same web dev skills that you have today. You can use the same tools you know, like Angular, and then start adding in these blockchain pieces. So experiment with Remix. Build a tiny smart contract like what we're going to do today. And then you can graduate to these large blockchain dev frameworks like Hardhat, which is entirely built on TypeScript and manages the deployment of the contracts. But you still need Angular. You still need that front end to create that interaction and those magical moments. All right, so now we're going to go into a demo, but I want to explain this demo first because it's going to be a little bit new to a lot of people. So if you think about that monopoly, it was kind of a raffle, right? You had a bunch of entrants, you had a bunch of people that had a chance of winning, and you had to pick someone that was going to win. And they violated the trust, and they were keeping all of those winning prizes for themselves. So we're going to build a raffle that anyone could enter, and then we're going to fairly pick a prize. And then I'm going to use that contract that I create, and I'm going to paste that into an Angular app, and I'm actually going to get access to interact with it. So when we think about fair raffles, how do you actually pick a winner fairly? Because no one, not even me, should be able to manipulate the results. And that's fundamentally a hard problem, but there exists a solution today, and it's called VRF, or Verifiable Random Function. So this was invented by cryptographers even before blockchain was a thing, right? Back in 1999, this was first talked about. And effectively, what you have is you have an independent party that is taking some sort of seed, some sort of source. They're applying a secret function to it that creates randomness, and then publishing that out in a way that uses their private and public key. So that anyone that looks at that number that you get out based on the seed, you can say, yes, I can guarantee that this random number came from that source. And so because if they tried to manipulate it, if you gave them a 5 and they were supposed to give you a 15 and they gave you a 16, because we have their public key, we can actually verify, no, that's actually not the right number that corresponds with that function that they applied. And so it has this very, very nice property of being able to get true randomness that's not manipulable. So I'm going to do a few steps. So first I'm going to start on the blockchain side of the world. I'm going to open Remix, this web-based IDE, and I'm going to open an example from our company's documentation. Then I'm going to turn it into a very simple raffle where we're going to have entrants and we're going to have a winner. And then I'm going to jump over to the front end and I'm actually going to connect to that raffle with an Angular application. I'm going to enter the raffle and I'm going to pick a winner. It's not going to be super flashy because I want to stay as close as possible to like bare code, but if everyone can bear with me, we're going to make mistakes along the way, but I think it's going to be a little bit of fun to actually see what this looks like. So let's dive in here. This is my son. He is not a good Angular developer. I'm trying, though. I'm trying. All right. So first thing we're going to do is I'm going to open up that Remix application. So I'm going to go to remix.ethereum.org, and I'm going to copy and paste some of the example code from the Chainlink website. So this is a sample contract. I'll explain it briefly. I'm not going to go in too far. I'll just close out of the tutorial, and we'll make it as big so hopefully people can see. All right, we're going to make a new contract. So this is the code that's going to be running decentrally on the blockchain, and I'm going to call it raffle.sol. So sol stands for Solidity. That's the language we're writing in. All right, so I'll just explain this contract very briefly. So again, it looks a lot like a JavaScript object. So you've got this object. It inherits from another set of code. And then I've got the connection to the blockchain that I'm going to be relying on here with these addresses. And then I've got a few things for randomness, like where am I going to store the randomness when I get it back. And then we've got two methods here that really matter. So request random words, so that's the contract code that initiates the connection to that independent backend. And then fulfill random words. This is the callback. When we get a random number, it's going to end up in this method. And so what I'm going to do is I'm going to take this contract and I'm going to modify it so we can use it for a raffle here. So first thing I'm going to do is instead of request random words, I'm going to call this pick winner. So this will be the method that we call when we want to choose who's won the raffle. Next thing I'm going to do is I'm going to create a enter method. So we're going to say a function enter that will allow me to enter the actual raffle. So in order to enter the raffle, we need a variable to store the entries. So we'll just say raffle variables. And what we'll do is we'll create two variables. So I'll create an array of addresses, one called entries, and I'll create an address that we store just for who won the raffle. And again, I'm keeping this as close as possible to the bare code, so we're not going to be doing too much fancy on top of this. And so the enter method is actually very simple. I'm going to take whoever sent the transaction, whoever said, I want to enter the raffle, so it's called message.sender, and then we're going to add them to the entries array. So we'll say entries.push, message.sender. All right, so now we have the ability to enter this raffle. Anyone that wants to on the entire blockchain can send a transaction to this contract, and they will enter the raffle and they'll get added to that array. Now, the other magic piece is once we hit pick a winner, we want to go ask for that fair randomness that we can't predict, we can't manipulate in any way, and we want to get that back and do something with that. So I'm just going to do that in this fulfill random words. This is the callback. And what I'm going to do is I'm going to say the winner is going to be equal to the entry that corresponds with the random words, the 0th entry in that, so you can get any amount of randomness you want back out. So I'm just using 1 here, and then mod that by entries.length, right? So if we only have 1 person enter, mod 1. If I have 10 people enter, it's going to be this big long random number, mod 10. And that actually should be it for our smart contract. So again, we've built a raffle now. It has a source of randomness, and we can check over here. This is the compilation tab, so we can compile it, make sure that it works. Great, no errors, that's a good sign. 1 step's good so far. And now what I'm going to do is, because you need another system to actually cooperate here, we call that an oracle sometimes, we're actually going to have to deploy this to a real blockchain. And so I'm going to deploy this to what's called a testnet. So this is a public testnet run by hundreds of computers around the world that people just participate in and say that this isn't for real money, right? This is just actually a pretend environment that simulates a real environment. So I'm going to take my contract and I'm going to deploy this. So even though it's a pretend, this is all made up money, I still have to actually do the transaction. And what should happen here is that now contract gets deployed, and now we actually have this deployed contract. So that exists on the blockchain now. And so I'm going to do a couple of things here. So I'm going to copy and paste that contract. And first, I'm going to use chain link subscription for VRF, which, oh, that's not good. We'll see how much we need to take out of the oven here. Pre-baked. There we go. All right. So we have no consumer. So a consumer is just a smart contract I've authorized to request randomness. I'm going to add that contract I just created. We will approve this. And then the second thing I'm going to do is I'm actually going to copy that ABI, that interface, and put it into this Angular app I've built. And so I'll explain the Angular app later if we have time, because we only have 2 minutes left, which time is going very, very quickly. So what I'm going to do is I'm going to go back to the compilation, and I'm going to copy the ABI. So it's just the interface. If you've ever used like Swagger, it's a similar idea where you have the model, you can export that and import it. So I'm going to go into this operator tool. I'm going to call this ng-conf, and I'll just paste this in. So again, it's just a big JSON that describes the signature of the contract. We'll go back home. We'll pick ng-conf, and now we need to paste in our contract address, which was over here. All right, so what this Angular app has done is because we have that ABI and know the entire signature, I can pump out all of those methods that exist on the blockchain so that we can just kind of pretend and call them. So anyone that's in red, that actually requires, it's a transaction, it modifies the state of the blockchain, and anything in blue is just kind of blank. So I can just see, we have no winner yet, we haven't requested a winner from the randomness source, anything like that. So let's go ahead and enter very quickly. All right, so we did a blockchain transaction. I've now entered the raffle. So now it takes the network a few seconds to actually go and confirm that. But what I can do while I'm waiting for that is we can take a look at that contract here in Snowtrace. So you can actually see all of this happening in real time on the blockchain, right? So you can see I created that contract. So again, this is verifiable, right? I cannot do anything. No one else can go and modify that contract. There's nothing I can do to kind of interfere with it. All right, and now we have 1 entry. That's probably enough for now. If anyone else is watching, you theoretically could have entered. This is all public. And what I'm going to do is I'm going to now pick winner. So we're going to go ahead and do another transaction. And so again, what this is going to do is this is going to submit a new request to an independent verifiable random source, and then they're going to call back that method for us. And what we should see is that in a few seconds, as soon as the blocks are confirmed, and then it sends a response, and then those blocks are confirmed, we will get a winner that is not 00000. So obviously, these are just large numbers that reflect the specific data. So the winner I'm looking for, if you look at, for example, this entries array, if I just ask for the 0th item in the entries array, This is my address, my wallet address that I'm using right now. And so if we've won, we should see that the winner is that address. And so we see we've done it. We've used a verifiably fair lottery on the blockchain to choose a winner. Awesome. So just a couple closing thoughts before we leave. So when you head home, I want everyone to remember that blockchain, yes, there is a lot of stuff going on the monetary, the financial, the currency side of things, but fundamentally underneath the hood, this is a dev tool. And so we can make of it what we want to make of it, right? You can build new things. Like you can build an anonymous Secret Santa app where no one ever sees the address except the intended participant, not even the organizers, right? Normally someone has that key somewhere, but you don't actually have to have that. You can have a fully decentralized system that works very well. So make sure you're using it responsibly. And I would say clone this repo and give this a try. So you should actually be able to see all the Angular code I wrote to list all the API, give you all the buttons that connect, et cetera. And then you also see the smart contract that we wrote here today. Thank you so much.